Good morning. My name is Jim Chou. I'm from the IBM Cloud Innovation Lab in Austin. The lab was spun out of IBM Research in various locations fairly recently, I think less than a year ago. It's full of really smart people, all of whom have multiple papers and patents. I am not one of those people. I actually am a developer. I joined the team about 3 months ago. I had worked for IBM previously, back in the 80s when Ethernet was 10 megabits and Ethernet and Token Ring were fighting it out. I've been at startups for the past 20 or so years. But I was excited by what this group was doing. There's a lot of challenging work to do. We're still hiring. That's our little ad. So if you're interested in working on leading edge stuff, go to IBM and look for Cloud Lab. So I work in the network virtualization group. I was happy to find out yesterday that network virtualization was only 7 years old, because that meant I was only 7 years behind instead of 20 years behind. Our current focus is actually on the control plane. When I was coming up to speed, I had looked at some of the papers, even from last year, and it looked like OVS was amazing. I mean, we basically have virtual LANs running at real wire speeds. And this was even last year before a lot of the changes that have gone in today. The control plane, though, seems to have issues. OVN is fairly new. It looks really, really promising. But we do need something to manage the virtual networks that we have in the clouds. Our focus is currently on availability and scalability of the control plane. We are not a research organization. We were spun out of research. We are primarily a development and operations group. We're just starting out. We're currently evaluating technologies, benchmarking, but we do intend to both develop, invent, and operate clouds. So the initial objectives that we had for OVN were basically to benchmark it both in startup conditions, in steady state, and in failure conditions. We would like to contribute improvements upstream eventually, and we'd like to use OVN to implement and operate clouds, starting from small private clouds and eventually going to hyperscale, hyperconverged data centers. So our goals are not just to create benchmarks, but to develop a framework for automated benchmarking. We'd like to be able to replicate the tests as OVN code evolves, and we want to be able to compare the performance of OVN on different platforms easily. We also don't just want to benchmark. We would like to be able to model workloads before we actually push this stuff out to live cloud. We also, because we are a development and operations group, we want to develop deployment tools as well. And we will also be operating live networks. The initial focus was basically, how do we test OVN at scale? When I first started looking at this, it looked pretty complicated, and I thought I would be using something like OpenStack Rally, which may be difficult to set up, but after it's set up, you can run it, and you get lots of pretty pictures out. But the problem with Rally is that it's really tied to OpenStack, and it's good for testing and benchmarking, not so good for the other things that we needed to do. Our requirements are that we want to be able to run both on bare metal and virtual machines. The tools need to be scalable. We want automation, and we want things to be able to be replicated. And it turned out that after looking at Sandbox, at the OVN Sandbox, it basically gets rid of a lot of the scalability issues that I was initially worried about when I was looking at OVN benchmarking. With just minor modifications to the script, you can have multiple instances of OVN running on your virtual machine. You don't even need a container. If you want to do data plane stuff, you do need a container. But for control plane stuff, you can just run OVN and disable the open vSwitch talking to OpenFlow. The majority of the work that we've been doing is actually on orchestration, building the code, provisioning the test bed, and then testing and evaluation. So what we are currently using is Ansible. That is the hot orchestration tool. We can apply to different test beds easily. We can parameterize it. We can use it to deploy and synchronize across multiple machines. And we can use it to retrieve data. Of course, it eventually just depends on scripts underneath. So we use Ansible for the orchestration pieces, and then we have some small scripts to run tests and to analyze data. If you looked at Ansible, it's basically role-based, or they want you to make it a role-based system where you think of roles and then you assign machines to roles. So for our system, we have a master, a builder, and a distributor. The master can be your laptop, or it can be a Jenkins machine. It runs the primary Ansible. It sets up the test bed, and then it runs your tests. The builder is the machine that installs the packages that you need to install OVN. It retrieves code from the repositories directly. You can specify the repositories and specific versions. It compiles the code, and it also installs the needed packages on the distributors and copies code to the distributors. The distributors install needed packages on lower-level distributors or endpoints, and it deploys code to lower-level distributors or endpoints. I think this picture will make it a little bit clearer. So basically, your master runs on your laptop or on a Jenkins build slave. Your test bed is a cloud. These are my first set of foils in like 20 years, so I didn't quite know how to make a cloud picture. So your test bed can be a little fleet of VMs on your laptop, or it can actually be like a real cloud. We separate out the builder and the distributor tasks and the master, because in a lot of clouds, most of your machines will not have connectivity to the external internet. They will only have connectivity on their private network. So the idea is that the master does the primary orchestration, but your builders and your distributors operate within your cloud, which may be on your inside a closed network for scale and to increase isolation. In terms of concepts, we have the controller. That's where OVN North D is, and the primary OVSDB-server. The endpoints are where you have instances of OVN running in sandboxes. Each endpoint can be a virtual machine or a bare metal machine. Ansible doesn't care, as long as you have the ability to access those endpoints from the controller. So this is a little sample of how you invoke the tests. For example, the first line is called setup test bed. You invoke Ansible playbook, you give it an inventory file, and then the setup test bed is the actual Ansible work file. And this sets all your test beds machines up. And you can use it you can define different repositories and versions, as I've said previously. And what this does is it basically goes out to your builders, tells your builders to pull code down from the repositories, whether it's the OVS head or your internal mirrors. It builds the code. It creates the install packages if that's what you want to install. and deploy instead of the actual build tree. And then it pushes the code down to the distributors. And the distributors take care of pushing the code out to all your endpoints if you need that scale. As I said previously, for purposes of control plane testing, it actually doesn't look like we need something this complicated, at least scaling up to past several thousand machines. The next line is an instance of how you actually run a test. Basically, it's the same format. You start a playbook, you give it an inventory file, and you give it the test name. And this one is parameterized with a number of instances per endpoint. So this is just telling Ansible that you want to run this test against a certain set of machines. And if you want to run on a hardware network or a cloud network, you just change your inventory file. Ansible also has the ability to create inventory files dynamically from various public clouds. So the inventory file doesn't even need to be static. The parameters are really powerful because then you can go ahead and automate even on top of Ansible. So this particular test is basically just a primary network startup test where we have a controller running NorthD and the OVSDB-server on one machine and a bunch of endpoints coming up and connecting to that server. And the instances is the number of instances per chassis or per bare metal machine. So in your inventory file, you define the number of endpoints that you have, whether it's 1 or 1,000. And on each of those machines, Ansible will go ahead and start up the test with the number of instances that you choose to run on each of those machines. The hosts can also be individually parameterized. So when these are all just basic features of Ansible that we did not need to do any work for. If you want some hosts to be bare metal machines and some hosts to be virtual machines, Ansible doesn't care. If you want some hosts to run lots of instances of OVN, you can just set specific instances for the host. If you want some of your hosts to actually be live data plane hosts, you can just run one instance and enable connection to OpenFlow and vSwitch on that specific machine. So it's very flexible without a whole lot of work. So currently, we just have previews of the work that we're doing. So this is the network startup test running against one virtual machine. So we have two instances. These charts are automatically generated. So part of the scripting on the machines is to start system accounting and to insert accounting rules in IP tables. So when you start, when Ansible starts your test running on the controller and on the endpoints, what it first does is it starts the accounting. It adds the IP tables accounting rules. Then it runs the modified sandbox script to bring up your daemons. At the end of the test, what it will do is it will shut down the daemons, remove the IP tables rules. It will then go ahead and post-process the SAR files and the IP tables outputs and generate these graphs. So anytime you run the test, you automatically get this graph out. So this is just with two instances. It's just the baseline. This is what a developer would usually do just to check his testing code. So as you can see, when the system first starts up, there's a lot of CPU load from the test starting up, and then in the middle, those are the daemons starting up. And this is just with just two instances, so there's not really anything to see, except you can see a little blip at the end where the test is ending. This is a graph with the number of instances set to 100. Again, there doesn't look to be much stress on OVSDB. These graphs are from the controller, by the way, where NorthD is running. The graphs are also created on each endpoint, but they're less interesting because we don't expect there to be a lot of utilization on the endpoints. As you can see, there's, again, not much load with 100 endpoints. And this is with 1,000 instances. So all these tests are run just by running that same script and just changing the instance number. So this is a little more interesting because you see like 3 spikes in the middle instead of 1. And at the end, you see a huge spike as the test systems start going down. So this is something that we need to investigate further. So what we learned from this is that testing OVN at scale is not very difficult at all with the sandbox. I mean, the sandbox is just awesome. And also, Ansible is awesome. But I would say make sure you understand YAML and Jinja 2 first, because otherwise you'll spend a lot of time tearing your hair out over extra spaces and lines and so on. All right, are there any questions?
All right, let's thank our speaker. Let's stay up here for questions. If anybody has a question, please come up to one of the microphones.
So in your next step on congestion, or well, I call it congestion, system congestion, are you just going to analyze it by testing, or are you going to start doing modeling, out of curiosity?
Well, we intend to do both. But first, we have to do testing to see what the interesting points are. Because without the benchmarking, you don't know where you're likely to find stuff. And after you've benchmarked your system, then you can take parameters from live clouds and start feeding them into your model. Like, for example, if you're interested in how network latency affects your system, you can set up NetM on your OVN machine and model networks that way. So you can do all sorts of stuff once you get the basic test platform running. And you can use it for both modeling as well as benchmarking.
Okay, maybe we should talk offline. Okay.
So the framework you use for testing, is it available in the public domain?
We intend to make it available eventually. IBM is very open source. And for large projects such as OpenStack and Eclipse, any group within IBM is free to make their code available. For smaller projects, including OVS and other code that you have to make available, you have to go through an approval process, which is separate for each group. So our group has just started doing that. But we do intend to eventually make this code available. Are there any other questions?
All right, let's thank our speaker one more time.